Reasoning with the resolution principle is analogous to reasoning with other rules of inference. We start with our premises. We apply the rule to the premises to derive some conclusions. We apply the rule again to those conclusions, and so forth, until we reach our ultimate conclusion or run out of things to do. As with propositional resolution, we define a resolution derivation of a conclusion from a set of premises to be a finite sequence of clauses terminating in the conclusion, in which each clause is either a premise or the result of applying the resolution principle to earlier members of the sequence. And, as with propositional resolution, we do not use the word proof here, because we reserve that word for a slightly different concept, which is discussed in a later segment. As an example, consider a problem in the area of kinship relations. Suppose we know that Art is the parent of Bob and Bud. Suppose we know that Bob is the parent of Cal, and suppose that Bud is the parent of Co. Suppose we also know that grandparents are parents of parents. Starting with these premises, we can use resolution to conclude that Art's the grandparent of Co. We start with our 5 premises, 4 simple clauses for the 4 simple facts about the parent relation, P, and 1 more complex clause capturing the definition of the grandparent relation, G, in terms of P. Start by resolving the clause on line 1 with the clause on line 5 to produce the clause on line 6. Here X is bound to Art and Y is bound to Bob. We then resolve the clause on line 3 with this result to derive the conclusion that Art is the grandparent of Cal. And that's interesting, but that's not what we set out to prove. We're interested in Co. So we continue the process. We next resolve the clause on line 2 with the clause on line 5 to produce the clause on line 8, with X bound to Art and Y bound to Bud in this case. Then we resolve the clause on line 4 with this result to produce the clause on line 9, which is exactly what we set out to prove. Okay, one thing to notice about this derivation is that there are some useless dead ends. We first tried resolving the fact about Art and Bob before getting around to trying the fact about Art and Bud. Resolution doesn't eliminate all search. However, at no time do we ever have to make an arbitrary assumption or an arbitrary choice of a binding for a variable. The absence of such arbitrary choices is why resolution is so much more focused than natural deduction systems like Fitch. Another worthwhile observation about relational resolution is that, unlike Fitch, relational resolution frequently terminates even when there's no derivation of the desired result. Suppose, for example, we were interested in the question of whether Cal is the grandparent of Art. The sentence, of course, does not follow from the premises. And resolution is sound, so it would never generate this result. The interesting thing is that, in this case, the attempt to derive this result would eventually terminate. With the premises given, there are a few more resolutions we could do, for example, resolving the clause on line 1 with the second literal in the clause on line 5, and so forth. There would be a few more such cases. However, having done these additional resolutions, we'd find ourselves with nothing left to do, and, unlike Fitch, the process would terminate. Unfortunately, like propositional resolution, relational resolution is not generatively complete. That is, it's not possible to find resolution derivations for all clauses that are logically entailed by a set of premise clauses. For example, the clause P of A or not P of A is always true, and so it's logically entailed by any set of premises, including the empty set of premises. Relational resolution requires some premises to have any effect, so given an empty set of premises, we would not be able to derive any conclusions, including this valid clause. Although relational resolution is not generatively complete, problems like this are solved by simply negating the goal and demonstrating the resulting set of sentences is unsatisfiable.